Hello, you're welcome to this new meeting or tutorial of DirimSi IT Zoom. And we're going to work on the continuation of the module of data analysis. So, you have already worked on the statistical analysis with R. So you already know how to do chi-square test, you know how to do Fisher test, you know how to do t-test, independent t-test, you know how to do the recursion test, you know how to do the Kruskal-Wallis test. Is it okay? It's clear now.
Mm-hmm.
So that's with R. Now we are going to try to do all what we did in the morning with Python. So I'll start by clearing all this. Now we use which data set in you remember the data set that we use in R now? It was Iris data set, not so.
Mm-hmm.
Now we are going to use also that same Iris data set by the Python. Now there was a module that you have to note that uses the Iris dataset, and that module is called the Seaborn module in Python. So to call it, you write import Seaborn as SB. Now I'll write Iris is equals to, I'll take that SB dot load dataset dataset, and then I put in bracket Iris. Are you getting?
Yes.
So this code is going to help me load the Iris dataset. Mm. So remember, I've told you to write the code PIP, blah 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 blah, and that PIP code was helping you. So download Spider. The Spider has an integrated IPython, so you can work in the graphic user in the command line of Spider with this code. Now,
Mm-hmm.
I've told you last time that if you want to get all the data sets that are located in Seaborn, you write SB dot instead get data set names, and then you close the bracket. So it's going this code is going to help you have all the names of the data sets that are in SB. I've given you also the same code in R for you to know the data sets that are integrated in R. These are data sets that are integrated in the Seaborn module inside Python. Okay, so I've created the iris dataset. Now I'm going to visualize the head of the iris dataset. So I'll write iris dot head. So this is the head of the iris dataset. Mhm. Now
Mm-hmm.
I will create similarly like other ones. I would like to do the chi-square test, and you know that for chi-square test, to do a chi-square test, you must have multiple categorical variables. I'm still going to create categorical variables. I created categorical variables for R. So let's say that when the sepal width is greater than 3, I'll call it, let's say that when the sepal width is greater than 3, I'll call it the high sepal width. And when it's less than 3, I'll call it low sepal width. And for the sepal length, when it's greater than 5, I'll call it high sepal length. And when it's less than 5, low sepal length. You remember now?
Yes.
So
The
this is,
5.5.
let's do 5.5. Thank you. So we come here, we create now a new variable which is called cat sepal width. So in order to use, last time we used the if else when we were in Python, we use the if else here. But you notice
Mm-hmm.
that in R you're not going to use the if else codes. You instead need to use the numpy library. So I'm going to first import numpy as np. So I'm going to use the import number in order to create those small variables. So I'll say category of the sepal width will be equals to what? NP dot where I'll now take what? I'll take the iris. So I'll work with the iris sepal length. sepal width, sorry. So iris sepal width. So if the iris sepal width is greater than 3.0, the value that it will have will be high sepal width. Else, if it is less than or equals to 3, it's going to have low sepal width. So that's it. So that's the same code. At the place of this np dot where, we instead had if else. Remember now?
Why?
Yes, give me 2 seconds, please.
Je prépare.
Hello?
D'accord.
Yes, give me 2 seconds. Okay, I'm done. So, hello? Hello? Hello?
Ouais, alors?
Okay, great. I'm done. Okay, so I am here. So when I've created down this cat, I'll bind the cat SW in this iris dataset. So how do you bind in Python? In R, we use the which function?
C'est bye.
And in
Unmuted.
Python, how do you bind?
C'est a fusion, no?
But it's not fusion. It's either you use concat, PT concat, or you use an integrated code. So the integrated code that you write is iris, then you put the name of the variable that you want. I'll say that the name will be cat, or I'll say that it's cat
S'il te plaît, monte un peu.
SW. It's still going to go down. I'll clear after. Cat SW. So I'll say cat SW will be equals
Je
to
ne vois
what?
pas. C'est qu'elle elle ne voit pas ce que tu écris.
Cat SW. Let me finish this and then I clear. CLS.
It's not too clear. I want to see what you are writing so that I can follow up.
Yes. I wanted to clear to show you. Okay.
Okay.
So now iris is now going to contain what? It's going to contain the cat SW, and the cat SW is going to have high sepal width, low sepal width. You understand now?
Mm-hmm.
So I'm now going to create again another variable that is going to contain now high and low sepal length. So tell me how to create. I'll write cat sl will be equals to, what should I write?
NP,
Np dot,
where
good.
iris
Np dot where iris here, what should I continue?
is greater than
What should I put
uncomfortable
here? What should I put inside iris here?
sepal length.
Good. Sepal length, and then I
Mm-hmm.
say is greater
Greater
than,
than
greater than what?
already 5.5 now.
5.5. Good. Now I wanted to tell you something because last time when I said that I'm going to give to the statistician, it's not because I don't know. If you realize, well, when I'm going to give you classes with statisticians, the statisticians they cram codes, while data scientists they produce codes. Are you getting?
Hello?
Hello?
Why?
I'm saying that in the morning when I was telling you that I'm going to send you statisticians, it's not that I
Mm-hmm.
don't know, it's that they generally with us data scientists we derive codes. Why statisticians already cram codes. They already have a
Mm-hmm.
format of codes. While with me and the other data scientists, you are going to see that they are always going to try to derive the code.
That.
Okay, so cat SL is equals to NP blah blah blah. So I'm now going to say comma. So I want that when it is greater than that, it should be called high what? Theta length, not so,
Mm-hmm.
comma. And when it is lower than, it will be called low theta length. So I will now add again into this new to this iris that I said. So I'll write iris square bracket. I'll write the cat SL. Cat SL will be the name of that new column. That cat SL will contain actually cat SL. So when I call again iris head, iris dot head. So I'm going to see now a variable that has cat SW and cat SM. Now, generally you realize that when you use iris head, it's going to show you a table in the command line. Are you getting?
Mm-hmm.
But now, if I want to have a table in the browser, just like R, because you know that when you wanted to have tables in the R browser, we use the GT
Mm-hmm.
summary tables. You realize that the GT summary tables, like table summary, was producing tables in the browser.
Mm-hmm.
Now, in order to have tables instead in a browser with Python, though it's a bit difficult, so I'm just going to tell you the code. You have to import now instead, you import dtable as, no, detail, sorry. Import detail as dt. So when you import detail as dt, now in order to use this iris dataset, you are going to say, let's say that I want to visualize this iris dataset within the web browser. So this detail is actually the module that helps you to visualize within the web browser. So I'll write now dt dot, I want to show what? I want to show the iris dataset. Then after showing that iris dataset, I will say open browser. Then I'll close. So realize that it's going to open now that iris dataset within a web browser. And that's going to be much more beautiful. Hello? Oui? José, va ouvrir le portail. Va ouvrir le portail. Ouvre le portail. Okay. So you realize here that what you have the iris data set that was shown here. You see now.
Yes.
Okay, so you have your category of SW here, category of SS. So you see that if you realize that the iris data set is poorly seen here, if you realize that the data set is poorly seen here, what you can do is that what you can try to visualize the data now within within the browser as such. So this browser is also very beautiful. You are capable of doing modification, like just like Excel. You're capable of doing modification on this browser and all the like. Okay, so that's to visualize the arrays data set within the browser. Now we are going to use now the code that will help you to do the chi-square and to do the t-test and all the like. Are you getting?
Mm-hmm.
Okay. So in this case, you remember which library that was used mainly for doing all those tables with the chi-square and all these things here. In R, what was the code? What was the major library that we used?
C'était pas ggplot,
The GT summary.
ggsummary.
So we use the GT summary in this case. Are you getting?
Mm-hmm.
But in this case, we're now going to use instead the library called table one. So I'm going to say import. Import table one as TB. Now, when I import table one as TB, this table one is the one that is going to help us to actually plot the difference, to have the chi-square, to have all the like that we want. Are you getting?
Yes, sir.
Okay, good. Now, let us start. Let's say that I want to create the cross tab. So I'll write cross tab. So I'll write cross tab. The cross tab will be equals to tb dot. The tb contains a function called table one. And you can decide to read the function table one by writing help. Let us just visualize now. If you want to have the help of the to know within the function table one, what are the elements that we use in the function table one? You write the help in bracket table blah 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 as such. So error. So when you have the help in bracket table one, what does it show? It tells you that it's going to the table one will take certain arguments. And that argument, the first argument is going to be data. And that data needs to be a pandas data frame. It should contain columns. And that column should be list. It should contain it should contain categorical variables. It should contain categorical variable which should be list. It should contain continuous variable which should be list. And you need to group by certain strings. So that's how, in addition to that, you can use certain things. The p-value. P-value can be set to be true or false. In addition to that, you have what is called down here. You have the H test name. H test name is going to be the test that it was used. Generally, you have to know that when you are using this chi-square, are you getting?
Yes.
When you are using test in the case of Python, you are not indicating which particular test the machine is doing. The machine is doing the test generally by default. You understand now?
Mm-hmm.
If you have a data set that the machine is supposed to do a Fisher test, the machine is going to do the Fisher test by default. If it's supposed to do a chi-square test, the machine is going to do a chi-square test by default. Now what you ask now is you ask the machine which test the machine use. So in Python, the machine will do that by default, but in R, you ask the machine to do a particular test. You understand now?
Mm-hmm.
Now let's visualize it. So here we have our right cross tab. So the cross tab will contain what? Will contain tb dot table one. So the first element that we said that should be inside the cross tab should be the data, and our data is called iris. It's clear now.
Mm-hmm.
The next we have columns. That's the second variable type. The second element was columns. So the columns will be equals to what? Columns will be equals to pardon. Columns will be equals to what? I want columns is actually the different elements that are going to be inside the um they are going to be inside the rows. They are actually saying column, but those are the different elements that are going to be inside the row. Because when you see that here, they say list of column in the data set to be included in the final table. So generally that's that with the columns. So I want that normally it's supposed to be rows, but here they said columns. I want that in my final data set I should have species and I should have category SW. I should have species and category SW. So I'll write species, comma, and make sure that the name of the species should be well spelled there. So this is the name of species here. This is cat SW. You should spell it very well. So I'll write species and I'll have cat SW. So it will be the columns. I'll put a comma. Then the next argument, we know that we have categorical. Categorical will be the list of columns that contain categorical variables. Actually, when they are saying columns here, they are actually the rows here. When they are saying column, I don't know why Python is actually saying column, but they are actually the rows that they are talking about. So the categorical variables is the list of the categorical variables for this particular column. So since species and cat SW are both categorical, I will just write categorical is equals to what? Is equals to, I put a list of what? I will take species. I'll take species and then I'll put a comma. I'll take species and then I'll put a comma. Then I'll put cat SW. Are you getting? Oh, and I'll put cat SW as such. Let me wipe this. Now the next thing again, I know that I have to close the bracket because table one has to close here. Now the next thing that I did not put, so I always have the columns, I have the category. I want to group it. Let's say I want to group it now by tag SL. So I'll put a comma, then I'll group by, make sure that you spell it like as such. Group by is equals to, I want to group it by what? I want to group it by cat SL. Are you getting? Are you with me? Dada Tijani? Dada Tijani, are you with me?
Yeah.
Okay, good. So and then I press enter. So all that has entered within the cross tab. Now, if I just want to visualize a cross tab within this my command line, I'll just write cross tab. So when I want to visualize it within the command line, I write cross tab. So you see that when you see it here, it's going to be very poor. You understand now? Are you getting?
Why?
On the command line, you see how it's very poor, it's not well arranged. So I'm going to open the browser in order to visualize it. So to open the browser in order to visualize it, what will I do? I will take dt dot show. I'll put
Doctor,
equals.
il va pas ce que tu écris.
Let me clear CLS. So in order to arrange that cross tab, I'll write dt dot show. Now, this is not a pandas data frame, so it's a table one data frame. So I'll write show one. I'll write cross tab dot table one dot what reset index because table one is arranging index such that it should not be well synchronized. Then I put dot open web browser. So that's it. That's the table that I've shown. So you see here that you have the species. The species you have Setosa versicolor virginica, and then it was grouped among. You have the group by SL. This is the overall SL. This is the high petal length and this is low petal length. So this is the overall. Now you see that Setosa, they are 3 year and they are 47 year, 39 and 11 year, 49 and 1 year. So you see how he has done. You understand now? Hello?
Why, sure.
Now let's say that I want to add a p-value. If I want to add a p-value, I'll just come on this initial thing here. That will just write comma, that initial code that I've written like that up. I'll just write comma, I'll write p-val is equals to what? Is equals to true. Then I'll write again dt show cross tab dot table one dot that. So you see that there is also a p-value, and you realize that the p-value is going to be less than 0.01, just like the code that we have did in R. You understand now? Are you getting? Hello? The first teacher, you are with me?
Sure.
Okay. So you realize that the code are similar, just like in R that we had, is still less than 0.01. Now, in this case, I've told you that you are not the one telling Python which particular test to use. Python is the one to use the test. If it cannot do the test, it's going to show a very bad error. So, in order to know now which test Python I use, you just put a comma and then you write H test name. H corresponds to hypothesis. So it is actually hypothesis step name. Hypothesis test name. Hypothesis test name we say is equals to what? Is equals to true. It's going to tell you which hypothesis test it has used in order to perform the statistical analysis. Are you understanding? Hello?
Sure, doctor. Ne t'inquiète pas,
Okay.
I'm hearing you.
So when I do that, I now go to the code above. I open now a new detail. So we realize here that the chi-square test was used for both of them to have the 0.01. So that's the explanation. Now we have done chi-square test. Now let's try to do now the t-test for continuous variable. So we do a same table like this, but we are now going to use continuous variable. So I will still take this. I will still go by cat sm, but now in this place it will not be categorical, but it will be continuous. Now I will have to take continuous variables. The continuous variables that I know that were located in this my data set. When I go to detail, I see that there was sepal length, there was sepal width, there was petal length. So let me just take petal length and petal width as continuous variable. So I'll come here and delete all this. So I'll write petal length, and then I'll write here petal width. Petal width. Similarly, I'll come up here and then I will replace the columns. I want that the columns should have petal. Actually, it's not columns, but the rows. Petal length and petal width. So petal width, and here is petal length. So you have your iris, you have your column, it should be continuous variable. I want that it should go by cat test, and then we'll put p value, and then we'll put the h test. But it will not be called again cost tab now. We better call it continuous tab, because cost tab you already have a name for cost tab above. So instead call it cont tab. Now I'm going to use again this DT cost table, but now I'll instead use now cont tab here in order to visualize it in a new web page. So what do you realize? You realize here that it's going to be grouped. You're going to have group by overall. Here you are going to have your means, you have your standard deviation, mean standard deviation. Now when it is grouped like that, you have the p-value, and you realize that it was a Welsh t-test that was used. Are you getting? Are you getting, Dr. Tijani?
You see now?
Okay. So from here we can say that you are capable of doing completely the test in Python and R. So you are complete. If you want to do the chi-square test, if you want to do the t-test, if you want to do the Wilcoxon test, if you want to do, generally you specify the test that you want to use in R than in Python. Python is much more like a programming language. So the machine is going to decide which one to use. Or if you want to decide than the machine, you are going to enter into steps of calculation that are going to be extreme. But in R, it is much more flexible. You're the one that is deciding which test to use, because you know that R is a statistical language. So that's generally what you have to know. Do you have any question? Hello? Dr. Tijani, do you have any question? Dr. Tijani? Hello? Okay, so I think that we can end the meeting of today, and then we will continue the next meeting. Are you getting, Dr. Tijani? We'll continue tomorrow.